We're now moving on to the third part of our Enterobacteriaceae lecture. And in this lecture, we're going to focus on the organism Salmonella. There are two species that are now recognized in the genus Salmonella. There used to be other species, but Salmonella has been reorganized. So the two species are Salmonella enterica and Salmonella bongorii. All of the previous Salmonella species are now serotypes. So there's Salmonella enterica, subspecies enterica, serotype typhi. So Salmonella gets very complicated. It's usually written out as Salmonella serotype typhi, or Salmonella serotype cholera suis, or Salmonella serotype paratyphi. Previously, all of these serotypes were individual species. The general features of Salmonella organisms, they infect both humans and animals, and animals serve as a common reservoir, especially poultry. Humans are usually infected through contaminated food or drink. Usually this is going to be fecal contaminated water, undercooked meat or poultry, as well as cross-contamination. So cutting something or using a cutting board and then putting something else on it and then eating it. Also, the Salmonella are non-lactose fermenters. So we said all of the Enterobacteriaceae ferment glucose. And I mentioned that lactose is commonly one of the carbohydrates that is used to differentiate between the Enterobacteriaceae members. So E. coli, what we talked about previously, is a lactose fermenter, whereas Salmonella is a non-lactose fermenter. So that's one way to differentiate at least those two organisms. So we will be mentioning the Enterobacteriaceae members and their fermentation capabilities. Salmonella also produces hydrogen sulfide. This is a very important distinguishing feature. There's only a couple of organisms that produce hydrogen sulfide within the Enterobacteriaceae family, and Salmonella is one of them. So when you see a question on the board exams or a question on an exam in this course, and it shows that there is a hydrogen sulfide producer, you always have to consider those organisms. And for those of you that are making separate charts, you might want to have a category of hydrogen sulfide production. We've already talked about a couple of organisms that produce hydrogen sulfide. One I can think of is Erysipelathrix ruseopathii. That is a gram-positive rod. Well, now we're in our Enterobacteriaceae. You can add Salmonella to the hydrogen sulfide producers. Salmonella is negative for indole, Voges Proskauer, PDA, and urease, and it will not grow on medium that contains potassium cyanide. It does have antigenic structures, such as the somatic O antigens and the flagellar H antigens, which are used to serologically group the Salmonella organisms. Some of the strains do have K antigens or can produce capsules. There's all different types of antigenic properties in Salmonella, and that's why Salmonella has been reorganized more recently to have a lot of these serotypes, and it's based on the antigenic structures. It has a heat-stable O antigen. It's a gram-negative organism, of course, lipopolysaccharide, which is endotoxin. It has flagella. It is a motile organism. Any organism that has flagella is motile. And the types of infection that Salmonella causes: enterocolitis, enteric fevers, septicemia, and there is also an asymptomatic carriage. So individuals that get infected with salmonella, they are infected. It's not normal flora, but they can carry the salmonella in their intestinal tract for a very, very long time. So gastroenteritis is one of the most common forms of food-borne infection. The salmonella that was a very common cause of gastroenteritis, it used to be Salmonella enteritis. However, it has been renamed to Salmonella enterica subspecies enterica. The common sources of infection include poultry, unpasteurized milk, eggs, as well as handling of infected animals. You can also get infected through contaminated cooking utensils and cutting boards. The infective dose of Salmonella causing gastroenteritis is 10 to the 6 bacteria, and the incubation period is 8 to 36 hours. So that's one thing. I took an epidemiology course in many years ago as part of a graduate course, and we had to go in and consider outbreaks and what might be causing the infection. And that incubation period gets very important because when people start going to the emergency room within a certain period of time after a picnic and you get 50 people that show up in the emergency room, that incubation period becomes very critical. It's also really important to look at this incubation period, 8 to 36 hours. So over a day later, you can start getting sick. And so many people think about, oh, what did I eat for lunch? You know, if you start getting ill at 3 o'clock, you're automatically thinking what you ate for lunch. You might consider what you ate for breakfast. You're not going to consider what you ate, 30 hours previously, usually. So Salmonella will cause symptoms anywhere from 8 hours to 36 hours after ingestion. So if you start getting sick an hour after you eat contaminated food, it likely is not Salmonella. It's likely 2 other organisms that we've already talked about that are not actually foodborne infections, but they are food poisoning, and I hope you all know exactly what they are. They are Staphylococcus aureus and Bacillus cereus. Those are 2 types of food poisoning. Remember, ingestion of preformed toxin. So Salmonella is an infection. It's not a food poisoning. It will last between 2 and 7 days, and the symptoms commonly include nausea, headache, vomiting, diarrhea, chills, and abdominal pain. Sometimes there's an enterotoxin, but the mechanism of that is not clear. Most cases of salmonellosis are self-limiting. Salmonella can also cause enteric fevers. So the clinical features are a prolonged fever. You can have bacteria in the bloodstream. It can get into the reticuloendothelial system, such as the liver, spleen, intestines. It can disseminate. It can infect multiple organs. This can lead to typhoid fever, which is commonly caused by Salmonella serotype typhi. So typhoid fever is a febrile disease that is the result of ingesting contaminated food, and usually the food will become infected by an infected individual or a carrier. So that's why in in restrooms, you'll see, employees must wash their hands before leaving the restroom. So let's say someone is carrying salmonella or they have salmonella, they use the restrooms, they don't wash their hands, they have some fecal material on their hands that you may not be able to see, but it's there, and then they go preparing food that isn't cooked, and then an individual can get sick. So there have been plenty of outbreaks documented that have been caused by that route. There's no known animal source for typhoid fever, Salmonella serotype typhi. Paratyphoid fevers are caused by Salmonella serotype paratyphi and serotype cholera suis. These are very similar to typhoid fever, but they're less severe. So enteric fevers are much more common in tropical and subtropical regions. They can develop between 9 and 14 days after ingestion. Usually the symptoms are going to depend on the infectious dose. So if you ingest a high infectious dose or a lot of organisms, you're going to get symptoms sooner than if you have fewer organisms ingested. Patients will initially have a fever, feel very tired, not want to eat, have muscle aches, and a dull frontal headache. The organisms are resistant to gastric acids. They'll generate inflammation in the small intestine. They'll invade into regional lymph nodes. They can get into the blood as well as the organs. And commonly with enteric fevers, you get these rose-colored spots on the skin. Bacteremia can also occur with Salmonella. Usually this is going to be the non-typhoidal Salmonella strains. The most common serotypes associated with bacteremia are serotype typhimurium, paratyphi, and cholera suis. You can more commonly observe bacteremia in two different groups. One is young children who will get fever and gastroenteritis and will have very brief episodes of bacteria in the blood, as well as adults who will get a transient bacteremia. So bacteria will go into the bacteria for a short period of time and only during episodes of gastroenteritis. Also, individuals can get septicemia, it'll get right into the bloodstream and not have any gastroenteritis at all. So once it gets into the bloodstream, it can go to the bones, the joints, the meninges, the cardiovascular system, you name it, it can get anywhere. Now there is a carrier state. Everyone's heard of Typhoid Mary. Typhoid Mary, an individual called Mary was her first name, had Salmonella. She carried the organism for many, many years. She actually worked as a cook, and she infected numerous individuals because she was carrying Salmonella and didn't know it. Even after she knew she was carrying Salmonella, they had to ban her from being a cook because she continued to infect individuals. So individuals who recover from infection can harbor the Salmonella organism in their gallbladder. They can excrete organisms in the stool, either all the time or intermittently. Sometimes it'll be there and sometimes it won't. So it's a very important source of infection, especially to susceptible individuals like immunocompromised individuals. And usually individuals that are carriers have to have extensive antimicrobial therapy as well as gallbladder removal. So here's Salmonella, some pictures of Salmonella. Salmonella is known to be transmitted in raw eggs, undercooked poultry. There is a reptile, the Komodo dragons. Those, how they actually kill, they are highly deadly reptiles. I believe they're reptiles. I have to look at that. I know there's a difference between reptiles and lizards. I believe they're a reptile. But the Komodo dragons, what they do is they have a large amount of salmonella in their saliva. So what the dragons do is they bite their prey and then they follow their prey. And eventually the prey will die from salmonella poisoning. They will get salmonella throughout their entire body, and then the Komodo dragons then call out, let their other Komodo dragon friends know that the prey is finally dropped, and they all come over and have a big old party. So that's kind of a little interesting thing about the Komodo dragons. And the other picture on this slide is the hydrogen sulfide production of salmonella. So on certain agar that will detect a differential agar that can detect hydrogen sulfide production in strains or organisms that can produce hydrogen sulfide turn a black color on these types of media. So this is a Salmonella case that was reviewed in Morbidity Mortality Weekly report, and this is a family that was vacationing in Wisconsin in July of 2004, and there was a 4-year-old girl that was taken to the emergency room with diarrhea and fever that she had for about 4 days. So it was recommended that the girl have a clear liquid diet and, just kind of drink some light broth fluid for a couple of days. The next day, the girl was taken back to the emergency room with bloody diarrhea, cramps, and a fever. So the stool cultures yielded Salmonella enterica serotype Pomona, which is a very rare serotype. So the child was placed on a 3-day course of antibiotics. In this case, it was trimethoprim sulfamethoxazole, and her illness recovered after 5 days. So of course, since this was such a rare serotype of Salmonella, the public health department came in and investigated it. So what happened was the family had purchased a small turtle at a souvenir shop in northwestern Wisconsin, and the family was warned of a link between turtles and salmonella. Actually, when I was a little kid, I wanted a turtle, and my mom wouldn't let me get a turtle because she said they all had salmonella. So there is a common known fact that turtles do carry salmonella. But the family bought the turtle anyway, and at least 3 other cases of salmonella in young children were reported between July and August of 2004, and all of those cases involved contact with pet turtles that were purchased at local souvenir shops. So this is going to end this section of our Enterobacteriaceae lecture, and we're going to move on to part 4.